Okay, hello. This is Erin talking through quiz 10, problems 1 and 4. So we have a loop with a specific diameter, the field. It's in a magnetic field which has a magnitude of 0.125 teslas directed into the plane of the paper. And then the loop is pulled at these 2 points and basically pulled shut into so that there's now 0 area, and over the course of 125 milliseconds. And the value of the resistance is 25 ohms. So to find the average electromagnetic field induced in the circuit, first I had to go through and figure out, what is the radius, since we're using area, which is pi r squared, and then also translate milliseconds into seconds so that it could be set up into this equation, which, as you see here, I have EMF equals change in flux over the change in time. And so basically, to find the change in flux, you find the you multiply the magnitude of the magnetic field by area 1 minus area 2 and divide that by the change in time. And since sorry, I'm looking on my word for a second. Oh, yeah, duh. Okay, so then plugged in, I already had B is 0.125 teslas, and then area 1 minus area 2, area 2 is 0, so all I need to find is area 1, which is pi r squared. So I have pi, and then r I found is, the diameter divided by 2, converted to meters, and that's squared, and then divided by 125 times 10 to the power of 3 seconds, and you get 4.418 times 10 to the power of negative 3 volts. So, well, I got, 4.418, yeah, because I rounded that right there. Okay, and then for number, problem 8, no, 4, what's the direction of the induced current? So because of Lenz's law, we know the induced current produces a magnetic field that opposes the change in magnetic flux. So as the loop is closing, the magnetic flux, which is downward and into the field, will decrease. Therefore, the flux is upwards and the induced magnetic field is into the page. So when you do that with the right-hand rule, it confirms that the current is clockwise. And another way I know this is because when we say the E, I forget what the term is for this E here, but this E, when it's bigger than 0, and your fingers and the current follow the same direction when you're doing the right-hand rule. But if it's less than 0, the opposite. So your fingers will be going the opposite way of the current, which is kind of how I figured out number 8. But also I just knew it was the same but opposite because it was going from 0 to bigger area. Therefore it was negative. Okay, so I think that's all. Thanks for listening.